Hey everyone, my name is Kelvin. I'm a developer and I make free tutorial content. If you like this kind of thing, consider subscribing and liking the video. And if you want to support me in other ways, you're always welcome to buy me a coffee. So today let's start with adding real data to the database. Now normally a lot of people would add a migration system at this point, but I think that's a little bit overkill because we don't have a live database, so we can just destroy our database and just set it up every time there's a new data change. So to do that, we're going to update the Docker Compose file, but before we do that, let's just run Docker Compose down. Now there's no output here for me because I already ran this, but there should be some if you have a running container at the moment. But in the Docker Compose file, what we'll add is a volumes. Alright, I hope I spelled that correctly. But what this will do is add the SQL directory of the root of our project into the Docker entry point. So we'll need a directory here. And this will run all SQL files in it to initialize the Postgres database. Now I'll still name these just like how we normally name migrations by 00 or numbering it so that it runs sequentially, just so we could like divvy it up and make it a little easier for us to go back and see what things we changed over time. But the first thing I want to do is just add extensions. And I'm going to add mod date time. This will help us with the database trigger of updated at. Now I'm not going to be using UUIDs, but in case you want to, you'll also need the UUID extension here. But for me, what I'm going to use is nano ID. This will be the IDs that I'm going to be using for my application, just because it's a little bit user-friendly, because you could change the length of this. And I believe on this thing there's a collision probability. So if you click this, you change the length of the ID and see how hard it is for a collision. And I generally like 14. It'll be this short, so we'll have friendlier URLs, but it's still pretty secure because it'll take 71,000 years to have a collision. Now, if I remember correctly, there's a link here for the Postgres version of it. It should be this one, the native function. And I'm just gonna copy this. So copy and add this as another initialization SQL file. 01 add nano ID. Boop. Now in the add extensions, I already added PG crypto, so this is a bit optional, but we can still have this here. The only change that I'm gonna make is to change the default size to 14 instead of 21. Optionally, you can also change the alphabet that is being used to create the nano ID, but I don't really see much of a reason to, so I'll leave it as it is. And then you can also read through this to kind of get a better understanding of how to write functions in PLPG-SQL, which is the programming language inside of Postgres. It's also highlighted here because you have to label the language that you're writing. So yeah. Now I'm not really of a DBA, so this is still kind of like above my head, but it's good to kind of like understand it, I suppose. And then finally, we're going to start with authentication. So the first table that we'll need is users. So we'll make another file and we'll do create. So we'll create a table called users with an ID field of type nano ID. I'm also going to add created at, which will default to now, and then updated at, which will be nullable. So it'll only be filled in whenever the users table, the table is updated. Or the row, I mean, that's the right terminology. And then for this project, I'm gonna go with username and password as the flow instead of email password, mostly because I think email verification is kind of out of scope for this project, but it is something I would like to revisit later in a different video. And then finally, let's also add a trigger so that updated at gets updated correctly. And this is going to be using the mod date time extension that we added in 00. But with that intact, we can run Docker Compose up. Mount path must be absolute. Did I write it incorrectly? Let me check this. I forgot a slash here. Okay, let's try this again. There we go. And you can see that it's doing all the creation. and adding the extensions. We can also check so we can run psql inside of the Docker container using the docker exec command. So -it is interactive, which means we'll have access to the terminal here. And then -u is the username, and -d is the database name. And all we need to do is check the description of the users table, which is how we expect it to look like. Now I'm not gonna do a insert here, mostly because the password here is gonna be holding the password hash, not a plain text password, because that would be insecure. But we could do a select nano ID just to check that our nano ID function is working as expected. So that should be 14 characters. And then if we do select nano ID with a different argument, so let's say 19, this should be a longer ID. And that's correct. So that's the database setup. Now we can start writing some code. So before anything, I want to do a go get, and we're gonna get the crypto package. This is the library that we're gonna use to hash the passwords, because the first thing I want to do before anything else is to see the database with a valid user. And we're gonna make a new file called password, which will be in a utility function or utility package inside of the pkg directory. And once again, this is more Go conventions, but all of our utility functions are things that we should be sharing throughout our project that isn't specifically private can go in here, the package directory. And we're gonna have two functions here, one to check the password and one to hash the password. The check password function is gonna use the bcrypt library that we just installed, and we'll be calling compare hash and password, which will take the hash and the password, but we have to convert it to a byte string, or a byte slice, rather than just a string. And similarly with hash passwords, we're going to be generating from the hash, or generating a hash from the password, where it takes a byte slice of the password string that we provide. And we do need to give it a cost. We'll just go with 14. And what we will return here is the string version of bytes and the error. Let's make sure I change the return type correctly. And these two functions will take care of the hashing and checking of the passwords for our users. Now to see the database, I'm going to make a command line, small little program, which will live in the command package, and it'll be called seed. But since we're going to be invoking this from the terminal, this will have to be package main, which also means the function here is main. But in this file, what we're going to do is connect to the database and then run our insertions from here. You know what, before we finish this, I think we also need to define the user, and I'm going to make a models directory called schemas, and this is going to hold all of our database schemas. What is inside of a table? Okay, so we have an ID, which is a string. We have created at and updated at. Updated at is a pointer. This is only because it's nullable, so we need Go to realize or respect that it can be null. And then username and password is also strings. We also need tag literals, and this is because in the database they are named differently. SQL has the underscore convention, so let's make sure that that's translated over correctly. And while it's not important right now, we can also add the JSON tag literals to give it the normal Pascal case that's more in convention of JSON and JavaScript. But of course, we're going to omit the password, which you can do by doing the dash here. And this way, it just won't be rendered when it's being sent to the API response. So with that, back in seed, now we can add a user's slice that includes the admin with the password that we're generating from hash password. And then we can now do an insert using SQLX's name execute. This will take the username and password from the model structs using the colon syntax. And then finally, if there's an error, we'll print that out. And if not, we'll print out the success. So we can run this as go run cmd seed main.go. We connected and we successfully inserted. And then using pSQL inside of Docker, we can also do a select to see our newly created user. So that's our seed. We can also update this later to add more users, maybe later even more of our other models that we're going to create in the database. Alright, let's go ahead and commit this change. That's quite a lot of code actually. Alright, I think that's good. We basically initialized the database. In the description, we're also adding all the minor steps that we also added, which is adding the SQL volume, the seed command, and then a little bit of our user schema. But now let's actually add to the API itself. And I'm going to be using the services and controller pattern, which is a more OOP or object-oriented design pattern where we're using dependency injections. Just to explain what that is, our server here has access to the Fiber app. The controllers are going to control all of the routes, and then our services is going to be purely responsible for all the database transactions. I'm not sure if that's the right word, but I'm going to go with that. And I think we'll start with services, which will be a new package, and we're going to go create a user service. So each of our services is going to be a struct, where one of the properties is the database connection. And with the struct, we're going to need a constructor, which takes in the database and returns a user service initialized with that database. And let's see, for authentication, we just need a get by and a create. So that'll be sign up and login. And I believe with logging in, we're gonna want to get the user by their username. So let's make the function get by username. And SQLX has a function called get, and this will get one row only. We'll bind it to our struct variable. We'll provide a select statement, and then the variable that we're using for this query is going to be the username string. And we really don't need to take care of the error here. We can just pass it along. So I'll just return the user and error. And we'll take care of the error in the controller. Let's also make the create, which takes in a username and password, both of which is a string, which there's a nice little shorthand where you can just add the type as the very last thing, and it'll just apply to everything before. Basically not return anything useful. It'll just return the raw, like this thing has been updated or this query has been ran successfully. And then it also has query X, where we can actually take useful database data back. And that's the one we're going to be using. So we could write a regular insert, but the query X is important because we'll be doing returning star. Let's also provide username and password, so it'll be filled in by these variables here, the $1 and 2. And if there's an error, we'll return that error, and we'll also return nothing for the user model. That is also why we need to make this a pointer. And finally, to grab the data from rows, we need to do rows.next. So then we could call struct scan on that row, and it'll bind the data to the variable or model user variable. And then to close out this function, we'll do return user and error. And let me just scroll down so that you see everything a little bit better. So I think this is all we need right now for the user service. Inside of new server, I'm going to make a little bit of space, and this is where we're going to initialize all of our user services. We're not using it right now, so I'm going to comment it out, but we will get back to this. Alright, now it's time for the controller. So that's going to be a new package called controllers. Controller. And just like service, we're going to follow the same pattern. We're going to make a struct and a constructor. This one I'm calling Auth controller, mostly because it's not so much a user controller as it is more responsible for authentication. It will need the user service, so that's going to be the one change here. Oh, I need the package with an S? That's not right. Let me just... Sorry, this is a small nitpick. I'm just going to change all of this to singular because I'm a crazy person. But actually, I just personally prefer my packages to be singular and my database tables to be plurals. A bit of a preference. But now that we're taking in the user service, we could add it to the controller struct. That way we'll have access to it in all of our methods. And the two methods that we will have is register and login. both of which are going to be fiber handlers, so it'll be taking in the fiber context as well as returning an error. This is pretty involved. I think the first step I'm going to do is make a new model called inputs, and this is where we're going to define the JSON body that we're getting from our REST API at these endpoints. And what we're expecting is the JSON body to be username and password, and both of which are going to be strings. So back in the auth controller, we could use the input model and use body parser to read the JSON body. And if we fail to parse, then we can return a new fiber error with a status code of bad request, which is a 400, and we can have the message say invalid request body. Next, we will hash the password. And with this error, we will return a bad request now saying invalid password. But then if we get this far, we should just run service.create, passing the input username and the hashed password that we generated. Alright, this error I want to be unauthorized, and I want this error to be obfuscated, so I'll just say registration error. Once we get this far, we should just return router.created, passing this context and a fiber map of the user, and that should be good for register. Now for login, it's pretty much the same. So let's grab this first portion and add that here. This time we're calling get by username, passing the input's username. Alright, I'm not in love with how we're handling these errors, but I think we'll get back to this a little later. But now we need to check the password. So the password string comes first, so that's the input password. And then the hash is the user's password. So user is the data coming back from the database. And then finally this will be a return router.ok. So register and login is the first attempt. We're not actually doing any real checking. We're not doing any authentication passes yet, but we're going to introduce JSON web tokens in a little bit. But as far as the controller functionality is, this is good enough to start testing. So back in server main, let's set up the controller and the services. And you know what? I think I'm going to change where all of the services are initialized. I'm going to add it to start, which means this will be s.db. And then controller we want to pass to set up routes. So we're going to need to change the arguments that it's taking in. So in routes, I'm just going to do UC, and this will be controller dot auth controller. And I'm not sure if I need a pointer yet, so I'm going to just add the thing. So that should take care of those endpoints. So back in main, we just need to pass in the user controller. Nope, that's definitely a pointer. So let's make sure that we change this to a pointer, and everything should be working. So let's test out our routes now. We'll just run air. That's a lot of stuff. I'll take care of that later. And let's open up. Let's see. This should still be working. Database is available. And we're going to go ahead and try and log in. JSON. So this is the user that we created in our seed, the admin with the password of password. And this should give us the correct user. Now let's try register. Oh, I messed up. These should not be gets. These should be posts. So make sure to change the API to register these routes as post requests. So if I do login again, everything should be the same. And if I change this to register, this should error out because admin should be unique and we get registration errors, which is correct. But if we change this to a different username, this should post and register correctly, and we have a new user. Now we need to actually start securing these two endpoints and making things a little bit better than this. But at least we do know that the routing is correct. Okay, so what we want to do now is to add JSON web token support and go into the website. For Fiber, I need to look for a middleware that'll actually help with this. And it looks like it's not one of the default ones, so it's probably in contrib. And we're looking for JSON web tokens, so it's gonna be this one. Now going down to the install, we already have the original fiber, so we're gonna need to do the go gets for the contrib package as well as the JWT package. So in the terminal, I'm just gonna paste that in, and that should download everything that we need. And now if we scroll down, we can check the examples. There's two types of JWT that we can use. There's HS256 and RS256. The one that we're going to be using is HS256 because RS256 is a private public key type of thing, and there's some generation to be had. We actually want a secret key that is in our environment variables, which is the one that we'll use for the H256 example. But from what you see in the example, all you really need to do is do an app.use. Now this is the Fiber app. And we're gonna also use the signing key from whatever secret that we're providing. So that's simple enough. I think this will want to be in server main. And we could just add it to new server where we set up the Fiber app. And it'll look a little bit like this. But since we do want this secret to come from our environment variables, we're gonna have to update our config as well as our .env file. So in our .env file, we'll add a new key called JWT secret. Now you can define this however you want. Right now I'm just going to use a placeholder just to get everything set up. And then config load.go. I'll add a new string here called JWT secret. And let's also follow the same convention that we did, which is to create a private getter function and call it in our load function. Make sure you use the right function actually. But once that's done, we can go back to our server main, replace the byte string that we are using for secret by the secret key from our config. You know what, this is actually a mistake. We don't want this middleware to be called on every route. We want this to be called on particular routes that we want authentications. So I think what I'm going to do instead is add the secret key to the struct. That way the server has access to it, and then we'll conditionally call the middleware when we need it. And this could be private because we're going to be calling this within setup routes, which is part of the struct. So now we can get rid of this, and we're actually going to move it to a different file. And I think I want to put that inside of a sub package called middleware inside router, and we'll create a public function here called authenticate. And this essentially will just return the JWT middleware where we provide the secret. Oh, that's what I'm missing. This returns a fiber handler. Alright. And in main.go, we can now get rid of this. And from here, we're going to go to auth.go in our controller. And I think I'm just going to create a new private function here called create token. So for create token, we're essentially going to be doing this. We're going to create the claims and creating the token. And we'll return the token, which should be make sure it's v5. But this token should be a pointer to a JWT token. So make sure the return type is correct. Now the claims is the JSON web tokens payload. And here we're going to decide what we want inside of it. I like having an expiration date, and I think an issue at would make sense too, which is just time.now. We don't really need to worry about admin rules. I don't think our application has any roles at the moment, but we do need a subject, which is an identifier for who this current user is. And since I only created a get by username, I think it would make sense to just add the username here, which means we need the username as a string coming in. And I actually made a mistake. We want to return the signed token, not the actual token itself. This also means we need to pass in the secret from here, which changes some things about the auth controller. I'm gonna make sure that we also have the secret coming in. Or you know what? Let's make this a method. That way we could also add the secret to the struct, which is a string. So that means we're going to change the signature of the constructor to also include a string for a secret. So then our private function can just do c.secret. This does change the fact that we need to update main.go to also pass in the JWT secret from the server struct. And now in the controller, we can call create token in both of our register and login routes. And I think I'll just add it to the very bottom of the error chain. C.create token with the username this is coming from user, so username. Add some error checking and also add the token to the response. We'll also do the same thing for login. And I think it is safe to just copy and paste. So I'll copy this, paste this here, and also add the token to the response. So that's us signing the token and sending it as a response, but we still need to use it. So we're gonna make a new route. Let's go with the convention of just calling it me. I'm not in love with this name, but I mean, it's fine. Now in the me function, we can grab the user's claims from the locals user JSON web token. And if you go into the middleware configuration, you can see that that's coming from the context key, which you could change. But from the claims, we could do a lookup to the username key, and get the value. We'll also cast it to a string so that we can call get by username on the service, passing in the username. Why is this wrong? That should be a string. Oh, that's right. This should be a different variable, so I'll do current user. So that will fix that, and we'll also use this as a refresh token endpoint. So I'll also add the token generation, so we can provide a way to get a new token. We'll also change this registration error to invalid token. I think that's fine enough. But now that we have a me route, we could create a new route inside of routes.go. I'll make a get request. I think I'll just call it me, but this will be the auth controller, me, and we also need our middleware, authenticate, and we need the JWT secret there, and that should be everything correct. One last thing, I need to check if is the normal bearer token. Yep. So it'll be bearer inside the authorization header. So with that, let's test out these new endpoints. So let's register username and password. There's our new response with the token, which we'll copy, add it to our headers, our auth header. I want a bearer token, and I think that's everything I need. So we'll do a get to API slash, I called it me, right? This should send back our current, no, it did not. And what is the interface is nil, not string. What? Wait, that's to do with bearer? Nope. Alright, I'll just add under this authorization bearer. Let's try that. No? I wonder what's wrong. Setup routes, s.jwt secrets. Okay, I know what I did wrong. Claims the key that we want is not username, it is subject or sub. So this is the wrong string or the wrong key. So with that, now this should go give us the correct response. And just to check if Insomnia is working correctly, I'm gonna get rid of this. We should get a missing or malformed JWT. I needed to change that. But that is technically correct. But I want to check if the bearer tab or the auth tab works, which it does. Okay. That's not actually related to the tutorial. I just want to check it. Alright, and then the last thing I want to do before committing is just to add a nice error handler so that we respond with JSON instead of just text. And I'm going to cheat a little bit. I'm going to look into the JWT middleware source code and go down to how they do their error handler, which is in their config file, and it's right here. So I'm going to copy this and create a private function based on the error handler that they've created. Now, this is JTMT where, and this goes into error handler, so error handler. And then I'm going to replace both of these returns with new fiber errors, and I'm kind of preserving the same error messages that was already being sent. And we can quickly test this by just turning off auth and sending a request. And now we have the correct error response, so everything is working correctly. So with that, let's kill our server and finally make a commit. Oh yeah, before we do that, let's actually run a go mod tidy, because we did install new packages, and we just want to make sure our go mod file is formatted correctly, or nicely. So that looks a little bit better. I think this is what I want our commit message to be. Overarching thing that we did was add authentication, but we added a user service, an auth controller, and JWT support, as well as structuring dependency injection, but I think this will do for now. And I should push this, so let's do that.